Welcome to another Panther Math session at Panther Math Corner. I am Dr. Howard. I'll be your math teacher or math tutor. Viva from the video that I'm recording. Today's session involves solving compound inequalities. And a compound inequality is based upon the definition that I have before you. A compound inequality is an inequality formed by joining two inequalities with the word and or the word or. And you're going to understand the difference between an and inequality and a or inequality involving compound inequalities. So the first inequality example that I will be showing, perhaps two examples of the solving each inequality with a and with the and formation. And you see this equation, the inequality, -4 less than x, -2 less than 3. And in solving this inequality, you always want to, just like when you solve an equation, you always want to have your variable by itself. But in this situation, you have your less than or your inequality relation signs. So you still solve it like a equation. With this difference, you have inequality signs. So in this case, you have a -2. You're going to add 2 on both sides of the inequality. All right. Normally, you would add maybe 2 constants involving a equation when you have an equation equals to another integer type. But in this case, you're adding 2 on both sides of the inequality. So with the inequality intact, the -2 and +2 cancels out. -4 or -4 plus 2 will give you a -2. Bring down this sign, inequality sign, less than x. And then add 3 plus 2. They are both positive. So that's 5 less than 5. So you have a interval between -2 less than x less than 5. Now, looking at this is a and. All right. How you know this is and? Because you have joint inequalities facing the same direction. All right. You're not going to have an and statement that has one inequality sign than the other one. They're all going to have the same directions. Maybe greater than or greater than equal. But you're not going to have a mixture of less than and greater than. That's impossible. All right. So let's graph the solution. All right. I'm going to put -2, +5. And this is going to be a closed interval because you have an interval between -2 and all the numbers that are x can be any number x that falls between -2 and 5. So it's going to be an open. All right. And then less than x. All right. So any number that is less than -2 and less than 5 is going to be in this interval. For example, -2 is less than 0 and 0 is less than 5. So all the numbers that are finite x will fall in this interval. And this is an open. It's not shaded. All right. Okay. Let's try another one. Let's do an example of another and equation. Okay, let's see. -3 less than -2x plus 1 less than 9. Now, in normal cases, for this one, you could split the inequality into two separate inequality statements. You could say like negative 4x less than x minus 2 and x minus 2 less than 3. But looking at it, you can solve it in one shot. All right, knowing that if you can do it on both sides, you're going to do the same thing on both sides. And you can keep the inequality signs intact. All right. Hopefully this will be a shortcut for you to, instead of just writing them as separate inequality signs, inequality equations. All right, let's look at this one. So if we know that, look, negative 3 less than negative 2x plus 1 less than positive 9. Again, we need to get this by itself, the number beside it. Now let's just do it in one shot as demonstrated in the previous example. Let's do this. Let's just subtract negative 1 on both sides. And this is straight line method, method 2. Because we can do it in one shot. We get rid of the number that's next to x, which is this constant positive 1, and we perform the cancellation here, and at the same time we're doing negative 1 on both sides of the inequality signs. This cancel, negative 3, negative 1, the sum of that. When you have two negatives, you have the same sign value, which will be negative 4. Bring down the less than sign. All right. Negative 2x. This cancels. Now you have a greater than, a less than equal sign. So you have one sign that's less than, and you have the other sign which is less than equal. So positive 9 minus 1 will be a positive 8. Like signs, you take the sum. Unlike signs, you take the difference, and depends upon which number of sign values are larger. In this case, positive 9 is larger, so the difference will be that, and the sign will be positive because that's how many positive. It's more positive than negative that you have here. All right. So the next step is to get x completely by itself. So we have to divide by. You have to divide by negative 2. Okay, divide by negative 2. But look, remember, when you have, when you divide a value that's in front, that's part of the x, something's going to happen with the signs. Okay. All right, and that was the last video about the c value being less than 0. So we're going to have this negative 2. When we divide by negative 2 on both sides of the inequality, the sign's going to change. The whole inequality sign is going to change. So let's do this. Negative 4, and I'm going to put a square just to show you what happens. All right. So if we divide by negative 2, this less than becomes greater than, okay? Divide by negative 2, all right? If we divide by negative 2 on this side less than equal becomes greater than equal, negative 2. So that's the trick, all right? Because these values that you're dividing would cause the signs to change. All right. Okay. Now, let me move it back a little bit. Negative 4 divided by negative 2 will give you a positive 2 greater than. This cancels. You have x, and then you have greater than equal to what? Negative 4. All right. Now, you can use this symbol to graph, or you can rewrite it in terms of less than. All right, let's do it with less than. All right, so we're gonna, we're gonna do this, we're gonna revert this, because in our understanding in writing inequalities in reference to less than, it's a lot easier because that's how the numbers on the number line are arranged. They are arranged by the values in terms of less than. And I'll demonstrate again. So if we rewrite this, I'm going to rewrite this, rewrite in terms of less than or less than equal. All right. So this becomes -4 less than equal to x less than 2. Now look at the sign. See the direction? All right. This is pointing to -4. That is pointing to -4. This right here is pointing to 2. This right here is pointing to 2. So we rewrote the inequality solution in terms of less than, and plus the direction of the signs are still pointing in the same direction. This tip is pointing to -4. When we rewrote the inequality sign in terms of less than, look, this is pointing to that. That two pointers are pointing to 2. This right here is pointing to 2. That's how you can check yourself, right, to make sure the direction is correct. All right, I'm going to graph it here. All right, so let's graph it in terms of less than. So we have -4 and a +2, and 0 is in the middle. All right, so this will be a open, closed. Yes, this will be closed because it's shaded. Draw a line to 2, and 2 is less than, will be open, not shaded. All right, so that's your interval for the n inequality solution. Okay. All right, I have one more to present. It's the inequality to solve with the OR. And the OR is going to be kind of easy because you're going to have just 2 separate solutions along with 2 separate inequalities that you have to solve to get the inequality solutions. All right, I'm going to just pause for a few seconds. I'm going to erase this. And again, just look back at this video, play it back to see what was done and the steps, and just look at it real carefully. All right, this is OR. All right, I'm going to give you one example for OR because this works the same way with the OR. All right. All right. Okay. All right, now solve the solution, solve 3y, it's too close, 3y minus 5 is less than 8, or 2y minus 1 is greater than 5. All right, we're going to solve both of them, and they're going to show a difference in the graphing of the solution, and then we're going to graph it. We'll graph. All right, let's solve this one first. This one right here, 3y minus 5 less than 8. It's very easy. Add 5 on both sides. Okay, 3y is less than 13. And this is And what we're going to do is, oh, I left the -8. I'm sorry. Let me go back. All right. Sorry. All right. That's my mistake. All right. This is -8. Okay. Correction. This is -8. It's not a +8. My apologies. All right. Okay. Let's try it again. 3y minus 5 less than -8. Okay. All right. So we're going to add 5 on both sides. All right, this cancels. -8 plus 3 will give you a -3. Less than 3y. All right. And then, to solve for y, we divide by 3 on both sides. Notice the inequality sign will not change because we're not dividing by -3. We're dividing by a +3. All right, so this cancels. Y is less than -1. Now on this side, we solve, make sure that's the correct solution. Yes. 2y minus 1 is greater than 5. All right, in this case, you're going to add 5 on both sides. Add 1 on both sides, excuse me. All right, 2y, this cancels, is greater than 5 plus 1, which is 6. And then we're going to divide by 2 on both sides. Again, we're not changing the inequality sign because we're not dividing it by a -2. If it was a -2 in front of a negative in front of 2y, then it would change the sign. But since it's not, the signs remain the same. This cancels, and y is greater than 3. 6 divided by 2 is 3. Now, we can graph. We have a graph that's going in opposite directions. All right, and -1 and 3. All right, y is less than -1. All the numbers that are less than -1 are going to the left. So it's an open circle going this way. All the numbers going to the left are getting smaller, so that's where it's going. And then y is greater than 3. All the numbers that on the right side of 3 are greater. So this is going to the right of 3. And notice that they are both open graphs, open intervals. All right, open intervals mean that it's one is less than and one is greater than. If it's less than equal or greater than equal, then the circles will be closed. Okay, please review the video if you missed some steps. Again, I apologize for the slight mistakes in the video, but most importantly, get an understanding of solving inequalities, especially compound inequalities. This is another Panther Math Corner, and my name is Dr. Howard, and thank you for joining me. Join me next time in Panther Math Corner, at the Panther Math Corner. Have a good day.